Hey everyone, in this video we're going to talk about primitive data types and creating variables in Objective-C. What I have running right here is a command line application. If you don't know how to get here, go ahead and watch the previous video in the series and I'll show you how. You're going to see some code right here. It's going to be a log statement that said your code goes here, and a log statement, well, some commented code and a log statement that says hello world. We're going to get rid of all that stuff. What we're going to do here is we're actually going to start writing Objective-C code, but more of it is going to be C code. What I mean by that is Objective-C is C. They're the same language. Objective-C just has more on top of it. Objective-C is C with more stuff. That's more powerful, more complex. But we're going to stick with some of the C stuff because it's part of Objective-C, but the primitive side, the C side of the language. So let's just go ahead and create some variables so I can show you what I mean. Integer number of wheels. So we're creating a variable called number of wheels, and it is of type integer, and it ends with a semicolon. Next variable we're going to make is of data type double, and it's going to be called weight in grams. Then we're going to make data type boolean, and it's going to be called is even. Okay, a couple things here. If you notice, I ended every statement with the semicolon. You have to do that in Objective-C. It's a way to let Objective-C know that you're done with the current statement, moving on to something else. If you leave one out, no worries. Xcode will let you know that you made a mistake and will correct you. So, another thing you might have noticed is that I started every variable name with a lowercase letter, and every subsequent word started with an uppercase letter. This is called camel case, and it's a popular convention in many programming languages. You're going to want to do that every time you make a variable name. You can make it all uppercase, all lowercase, start with an uppercase, but it's just not convention. Other people reading your code are going to be confused. This is how variables are named in Objective-C. If you started it with an uppercase N for number of wheels, it would seem like a class, which you're going to see later on. It's just confusing to the eyes, so you're going to want to stick with camel case. You can put numbers in the variable names too. It doesn't matter. If you start with the numbers, you'll get an error. So just be mindful of that. And be mindful of what you name your variables, because your variables represent things. So you don't want the name to be XJ32 when it represents something like the number of wheels. You want to call it number of wheels. Okay, let's talk about what these data types are. Int, double, bool. Integer, double, and boolean. These are primitive data types. There are plenty more. I think we can get by with just these three. Feel free to Google C primitive data types or C data types, and you'll learn more about all the different kinds. Right now we're going to stick with these three. What an integer is, and these come up a lot, is a whole number. Let's go ahead and assign this a value of 4, number of wheels. Integer is a whole number. It could be positive or negative. We can write the value of number of wheels right here. We can give it a value, or we can do it later on. Let's go ahead and do it later on. Number of wheels, Xcode will autocomplete number of wheels for us because we've already declared that variable. We'll set that to 4. Okay, now double. Double is a double precision number. It's a floating point number. What it means is that here we can start to incorporate decimal places, and a lot of them, because double is double precision. There's another data type called a float, right over here, float. And a float is a floating point number just like a double, except it's just half as precise as a double. Double is twice as precise. You might be wondering, why would we ever use a float then if it's half as precise? Well, the reason for that is because floats take up less space in memory. It's not really important for any of our needs, so I just want you to default to double. If you're building a big complicated system where a lot of floats are being generated, or you might want to use float instead of double. Save some space, but for the most part we're going to use double. So let's give weight in grams a value. We can give it 43.235, so more precise number. And we'll give bool a value. We'll give is even a boolean value. Make that yes. In Objective-C, a boolean can either be yes or no. It's representing the computer as zeros and ones, 0 being no, 1 being yes. So this is going to be set to yes, to 1. All right, so we have our variables here. We can change them along the way. If I want to go ahead and change the value of number of wheels, I can change to 6. because variables can be changed. We use them to store data and to manipulate data. It's a container for our data. But we can make it a constant with the keyword const. And here we're going to get some errors because constant means that we can't change the value once we declare it. So we don't want that, so we'll get rid of the constant. And we'll get rid of this. So just a few things about these primitive data types is you have to really consider what type of data you need to use. If you're doing anything that requires precision past the whole number, you want to use a double. I'll give you an example right here. If we make a variable called answer, and we make it an integer, and we set it to 9 divided by 4, right? And don't mind this nslog statement. I'm going to cover it later on. Basically what we're doing is logging this to the console. I'm using this %d token. %d designates an integer, and I'm going to put the answer variable. So you want to print whatever the answer variable is. We got 2. 2. It's just a little strange because we're doing 9 divided by 4. That should be 2 1/4. Why are we getting 2? You might be able to see that if you were writing some big program where precision mattered, this would be a huge bug, a huge error. So you need to account for that and make sure your data types are correct. Even if I make this a double, I'm still going to have problems. Check it out. Well, here's the first problem, is this token is a D that represents an integer. We want an F, which represents a floating point number. So here we have 2. Well, we made it a double, and we set the token to F. Why are we still getting 2? Shouldn't we get 2 1/4? The reason for this is, yeah, we're storing it in a double. We have all these decimal places, all this precision, but it's still not what we want. We have 9 divided by 4. Now, Objective-C reads this 9 and this 4 as integers. So an integer divided by an integer is giving us another integer. There's two things we can do here. We can either typecast this as double, so we're really forcing the answer to be given to us as a double. So here we're getting 2.25. Or the other option is we just give the decimal place. And now we have 2 doubles, and we're storing it in a double. We have 2.25. So that's just a brief overview of some of the primitive data types we're going to see along the way. We're going to see plenty of booleans, we're going to see doubles, and we're going to see integers. And also a little overview of how we're going to write our variable names, how we're going to organize them, how we're going to name them with camel case. We're going to end everything with semicolons, and how we have to write the type of the variable before we write the name of the variable. In some languages you don't have to do this, but in Objective-C we have to declare the type of the variable before we can create the variable. One last thing before we finish off this video is mentioning the other primitive types. We talked about booleans, integers, a little bit about floats and doubles, but here are some others. Not all, but others. A char is a single character. We'll get to that more when we talk about strings. We can ignore that for right now. But just everything from byte to double. I just want to show you that this increases in size. So this is the amount of space it takes up in memory, each one of these data types, and the ranges of the values that can be stored in this data type. So if you have a number greater than 127 or less than negative 128, you don't want to store in a byte. You're going to get errors and problems in your code. Same thing for integer. I know we said it stores a whole number, but it doesn't store a whole number that's greater than this value or less than this value, which is about 2.1 billion and negative 2.1 billion. If you have large numbers that exceed that, or numbers that are going to grow to exceed that or shrink, then you're going to want to store that in a long float or double. So be wary that you can't just arbitrarily store values in data types. You want to know what type of values you're going to be using and pick the data type accordingly. So it's a very, very large number stored in a double. It stores an enormously large number that I don't even know off the top of my head. It's very large. And if you're going to have numbers that range from 1 to 10 and you know they're never going to change, you can store them in a byte. You can store them in an integer. The difference in size in one variable is really not going to affect your program's memory that much. So it's more important to know that your data type is going to be able to hold the value that you want to store in the variable.